Good evening, class, and welcome to our performance management class. Today's class is going to be a short one, and I'm sorry, it's a short class. The topic is also a short topic. It's a continuation of capital budgeting. Today's topic is capital budgeting replacement theory. Now, we want to look at when we buy an asset, we make a capital expenditure. We said that after the asset will experience wear and tear, and it will depreciate. It will lose its value. And one of the things that you will observe when the asset is being depreciated or losing its value is that you keep repairing it constantly. You keep spending more money on maintenance. And when you spend more money on maintenance, the running cost increases. Then, when you want to sell the asset after some time, you find out that the price will be lower with each passing year. So there comes the assets, because the asset is not giving you optimal performance that you require. There comes a time you will change the assets. And so in our class today, this topic will help us to explain the technique All right, so we are going to look at two kinds of decisions to be made when replacing an asset or part of an asset. We're going to look at when to replace an asset that deteriorates over time, so it depreciates over time. Under that, we're going to be looking at if we ignore the time value of money. So what will be the best time to replace the assets? Then we will look at taking into account the time value of money. Now, both of them are the same. Both of them are the same. It's just the difference is the time value of money. Okay, the second one is when to replace an asset that fails suddenly. So it knocked off suddenly. When to replace the asset. If an asset is having that tendency. Now, under that, there are two kinds of decisions we do, whether to wait for when an actual failure occurs, then you replace it. Or should you replace the asset before the failure occurs. So when will you replace the asset before the failure occurs? In this class, we are not going to take this second part. We'll be looking at when to replace an asset that deteriorates over time. We're going to take question on that, but we'll discuss the two. Now, replacing assets that deteriorate over time, ignoring time value of money. This type of decision is about determining the most appropriate, useful economic life of a non-current asset. The approach is to evaluate the cycle of replacing the machine, considering the various options of how long it should be kept before it is replaced. Decision rule. Pay attention to decision rule. The preferred replacement cycle of an asset should be the one that will give you the least cost, should be the least cost replacement cycle. What do we mean by replacement cycle? Okay, replacement cycle is the frequency of replacement. Okay, so now let's say you have a motor vehicle and you can either replace the motor vehicle after every 4 years. Now, it means that once in 4 years, you replace the vehicle. So in 12 years, you must have replaced your vehicles 3 times. So each replacement cycle is 4 years. Now, another could say, why not replace it every 3 years? So in 12 years now, you would have replaced 4 times. So 3 years is a replacement cycle. Another could say, let's replace every 2 years. So every 2 years, you keep replacing. So in a 12-year period, you would have replaced 6 times. Another could say, let's replace every 1 year. So there are some people who replace their vehicles every 1 year. So you have 12 replacements in a 12-year period. We even know people who replace their cars in 6 months' time. Okay, so that's the kind of thing we'll be looking at. We are going to be looking at the decision rule is this one that will give you the least costs in each replacement cycle. All right, so let's look at the B part now. Here says asset replacement, taking value of money into account. Now, when we say time value of money, we are looking at the present value of future cash flows. The prominent method used under this technique is what we call the equivalent annual cost method, which is what we are going to solve today. The relevant cash flow used in these decisions is 1, the capital cost. Now, the capital cost is the purchase cost of the assets. So it means that one of the relevant costs is how much did you buy the assets? Then we're going to consider the maintenance or operating cost of the asset. It means for you to use that asset, you must be running it, you must be maintaining it, you must be repairing it. So what are those costs? These costs will usually increase as the asset gets older. Then we're also going to consider the scrap value or resale value of the asset at the end of its life. So what we're basically going to do is at each replacement cycle, we're going to consider the scrap value as at that time. And so the equivalent annual cost of replacing every n years will be the NPV of cost over one replacement cycle. We're going to explain that when we solve the question. So the equivalent annual cost is simply if you are going to replace the assets every 1 year, what is the annual equivalent cost you are going to be making each year? If you are going to replace the asset every 2 years, what is the equivalent cost you are going to be making each year for the 2 years? If you are going to replace the asset in 3 years' time, what is the equivalent annual cost you will be making each year? So whichever gives you the lowest equivalent annual cost, that is this one that you are going to accept. So that's what we are going to be doing. Then we have replacement component, replacing components. Now, assets considered earlier, we said these ones are deteriorating over time. But now this particular section is based on assets that fail suddenly. Most times, this applies to components of other assets. So it's not basically an asset, it's components of an. Basically, 3 different policies that can be used to replace them. We have what they call the individual replacement. Under this individual replacement, this policy, an item is replaced immediately when it fails and only when it fails. So it means that if an item fails, you replace it immediately and you don't replace any item that has not failed. Now, that's one method or policy. Another is called a group replacement. Under this policy, every item is replaced during a single stoppage, whether the item has failed or not. So it means that if, let's say you have a clock and the clock stopped working and there are 5 batteries working that clock, you replace all the batteries, whether the batteries are working or it's just only one that has stopped, that made the whole thing stop. You replace everything. Unlike the individual replacement where you identify that one that's failed and you replace it. Here you are replacing everything in the group. Also note that calculation might be complicated by the need to replace components that fail between each group replacement. Then there is the selective replacement. The relevant scenario is that a machine or production line contains a similar number of similar components where failure of a component does not necessarily stop the machine from working. This is the concept of redundancy. Now, like I said, we are going to be concentrating today's class on the first part, replacement of an asset that deteriorates over time. Now let's look at illustration 1 to see what we can gain from illustration 1. A company is considering its replacement policy for a peculiar machine. Now you see this is an asset, a machine. The machine has purchase cost of 20,000 naira and maximum useful life of 3 years. The following information is also relevant. Now look at the relevant information. Year 1, year 2, and year 3. We have maintenance cost. So you see here that the first year, since the machine is new, the maintenance cost will be low. Now, as you keep aging the assets, year 2, year 3, the maintenance cost increases. Now look at the scrap value. Because the asset is still new, the scrap value at the first year will be high. But as you keep aging the assets, the scrap value reduces. Required, determine the optimum replacement cycle if the cost of capital is 12%. Now, the mention of the word cost of capital tells us that we are going to use a time value of money. So I'm going to show you how to calculate with the time value of money, and I'm going to show you how to deal with the method of ignoring time value of money. Just a moment, let me get this calculator. All right, now let's get our solution page. All right, so solution. The first one is we want to see if we will replace the assets every year. So what are the relevant cash flows that we need to consider if we are to replace the assets every year? At year 0, that is when we bought the assets. So the cost of the assets we are told is how much? 20,000 naira. 20,000 naira. So that's the cost of the assets, 20,000 naira. Then in year 1, we find out that the maintenance cost. So why we put this 20,000 naira in bracket is an outflow. We spent the money to buy the assets. Maintenance cost is an outflow, 1,000 naira. So it's here, 1,000. Scrap value, when we sell the assets, this is like a revenue. So it's not in brackets. Now we're going to use the discount factor, that is DF, at 12%, which is the cost of capital. So for year 0, the discount factor always at year 0 is always 1. Discount factor for any percentage at year 0 is always 1. So when we multiply 1 times 20,000, our present value is 20,000 naira. Okay, so we go to year 1. The discount factor of 12% in year 1 is 0.893. You can use your, what do they call it? Your 4-figure table or your discount factor table. Okay. I could also show you how to calculate it. Let's see how we can calculate it. You can use a calculator to calculate it. So discount factor, let's see, let me take you to Excel to see it here. Our discount factor here is 12%. So let's say this is our discount factor, 12%. And let's convert it into decimal, which is 0.1. Okay. Then this is 100%. So we say this is 1 plus this. This means 1.12. Okay. Now the formula is 1 over 1 plus r raised to power the number of years. So I will simply say 1 divided by 1 plus r, which is this, raised to power, okay, let me now say 0. If I say 0, you see it has given me 1. Let me make it for 3 decimal places. So it has given me 1. That's how I got the 1. If I change this to raised to power 1, raised to power 1, it gives me 0.893. And that is 893 that we have here. So that's the 0.893 we have here. Okay, now let's go to the when we multiply 0.893 by 1000, we have 893. Then we go to the scrap value, which is 8000. We multiply it by the discount factor for year 1, which is 898. Somebody asked a question: how did you get the cost at year 0 to be 20,000? Okay, the question here says the machine has purchase cost of 20,000. So when you are buying it 20,000, that is your year 0. All right. Now we have our scrap value here, 8,000 naira, multiplied by the discount factor of 0.893. You have your 7,114. Now, what is the net present value? The net present value is the sum of all these present values. We have minus 20,000, we have minus 893, then we have plus 7,144. When we add them together, we're having a negative value of 13,749. Okay, so that's it. This is our NPV. Remember how we did NPV in the last class? We are taking that knowledge to this class. Our NPV is now negative. Why is it negative? This is because your costs far outweighs your revenue. The only revenue you have here is the scrap value. So your cost is higher than the revenue. That is not all. This is the net present value of all the costs year 0 times. Now we want to see what is the annual equivalent cost. It means how much does this translate to cost that we'll be making every year. So what you do is divide your net present value by the sum of the discount factor for each year. So this is year 1, so we only have one discount factor, which is 0.893. So that's why we use our net present value here, 13,749, and you divide by your year 1 discount factor. And now it has given you 15,396. That is the cost that you'll be spending every year if you decide to replace in year 1. Okay, we can decide to change our replacement strategy to replace at year 2. Let's see. In year 1, in year 0, the cost is still 20,000. Discount factor is still 1. Net present value is 20,000. Go to the maintenance of year 1. In year 1, we still pay our 1,000 naira maintenance at discount factor 0.893. You will still get your 893. No problem. But you didn't sell the assets at year 1, and so no scrap value will be recorded in year 1. You decide to take it over to year 2. You will now have your maintenance cost for year 2, we're told that the maintenance cost is 3,000. And so that is the maintenance cost for 3,000. What is the discount factor for year 2 if it is 12%? Let's go back to our discount factor and see. Okay, now let's go to our Excel. If I change this power to 2, wow, it has changed our discount factor to 0.797. So that is what you will still get if you were to use your discount factor table. So that is what we use here, 0.797. We multiply it by your 3,000 naira maintenance cost. It gives you 2,391. Now that is the cost present value for year 2. Now you decide to sell the asset in year 2 because you want to replace it. So your scrap value is 5,500. So you bring the 5,500 as a positive number, multiplied by the same discount factor for year 2. When you discount it to today's term, to year 0's term, it gives you 4,384. 384, yeah. So when you sum the present values from year 0 down to year 2, the net present value will give you 18,900. Now, that may seem to be higher than year 1 present value, but wait a moment. Let us check the annual equivalent cost. Now, the annual equivalent cost is going to be your NPV divided by the sum of the 2 years discount factor. So we have year 1, year 2. You add 0.893 plus 0.797. If you add those two, you are getting 1.690. So that is what you use to divide 18,900. You are having 11,183. What does this mean? It means that all the costs that you are making, the maintenance costs, the purchase cost, the maintenance costs, the scrap value, everything, it's equivalent to spending 11,183 every year. So compare it to year 1, that the equivalent is spending 15,396. Which would you want to spend? You would rather want to spend the lower figure. So if it means spending 11,183 every year for 2 years, I would rather take that than to spend 15,396 for just 1 year, including scrap value. It makes no value for you. So we've done year 1 and year 2. We saw that year 2 is better than year 1. So let's get down to year 3 and see if year 3 will be better. Okay, for year 0, it remains the same figure. Your year 1 maintenance figure still remains. Your year 2 maintenance figure still remains. Now, your year 3, you were told that the maintenance figure increased to 5,500. So that's it. Now let's see what is the discount factor for year 3. Somebody is still asking, how did we get this 1,690? It's not 1,690, 1.690. How we got it is this. Okay, let me get to my Excel and show you how we got it. All right. Now, this is for discount factor for year 1, 0.893. Okay, so let me do the same thing for year 2 and year 3. Now, this happens to be for year 2, I have 0.797. If I have to add year 1 and that gives me the 1.690. That is what I said we are going to use. Use the discount factor for year 1 plus the discount factor for year 2. You have your value to use to divide the MPV. Now let's look at year 3. Year 3 is the discount factor is 0.712. Now what will be the figure that we'll be using to divide the MPV? You add year 1 to that of year 2 to that of year 3. Gives you 2.402. So that's what we'll be using. So you see in year 3, we have our discount factor at 0.712. And when we got our net present value as 25,064, which is what we used there, we divided it by 2.402, which we got as the sum of year 1, year 2, and year 3 discount factors. Because we want to see how many years, what is the equivalent that we'll be using for each year. So it turns out that the equivalent annual cost gives us 10,435. And now that is the least cost for the whole 3 years, for the whole 3 policies. So conclusion, we should replace every 3 years because it has the lowest cost. So you can see that when we use time value of money, for time value of money, you need to discount everything to their present value. And you now add the present value to give you a net present value. Now, assuming we are to ignore time value of money, let's see how it will be like for year 1. Let's assume that we are to ignore time value of money. What will that be? Okay, so just a moment. All right. Now let's say this is our cost, 20,000. Okay. Then your maintenance is 1,000 naira. And your scrap value is 8,000 naira. Okay. Let me make them. All right. Now this is your cash flow. So there's not going to be a discount factor. All you simply do is sum them together. When you sum them together, you have 13,000. 13,000. Now you see that 13,000 is smaller. When we are done present value, we got something like 13,749. Okay, so what do you do? 13,000 is your cost, is your cash flow, your net cash flow. Now you divide your net cash flow by the number of years. So this is 13,000 divided by 1. It's giving you 13,000. So this is your equivalent annual cost for 1 year. Now, assuming you are doing for 2 years, for 2 years, how would that look like? You will have your costs, which is 20,000, and you have your maintenance for year 1, which is 1,000. You have maintenance for year 2, which is 3,000. And you have your scrap value, which is 5,000. Okay, so let me make them so well. All right. Now let's look for the sum. The sum, so you're not doing discount factor because there's no time value of money. You add them together, you have 18,500. If you remember when we did the present value, the net present value gave us 18,900. Now what do? You will now look for this sum that you've got in the net cash flow divided by 2 years. So remember, the method here is you're divided by the number of years. But when we are using time value of money, we are dividing it by the discount factor for the years. So now you have 9,250 each year, as against 11,183 each year. So you see, year 2, the cost is cheaper. We'll go to year 3 and let's see what we can do in year 3. In year 3, the cost is 20,000. Your scrap value for your maintenance cost for year 1 is still 1,000. Maintenance cost for year 2 is still 3,000. Maintenance cost for year 3 happens to be 5,500. And your scrap value is 3,000. Okay, so let me arrange them again. All right, now let me look for the sum. The sum here gives me 26,500. You know, when we are doing the equivalent method, the net present value gave us 25,064. Now this one is giving us 26,500. So here you simply say 26,500 divided by 3. That means you are going to be spending 8,833.33 every year. Now, as against the 10,435 every year. So this is how we solve without time value of money. And in the same way, we are still going to choose replacements every 3 years because it is the cheaper of all the replacement cycle. So whether we use the time value of money or we ignore it, we have the same value. In your exam, you may not be given the option to ignore time value of money, but we may still see that. But most times, you will be given to do the equivalent annual cost method. Okay, so that's it. Look at illustration 2, which I will give you as an assignment. TISA Limited is considering replacing its replacement policy for a particular machine The machine has purchase cost of 17,000 and a maximum useful life of 3 years. Now you can see the maintenance cost increasing with time, scrap value reducing with time. And we are giving the cost of capital to be 10%. Now determine the optimal replacement cycle using the annual equivalent method. Now that's an assignment for you. Now the other part that we didn't discuss today is about the other decision making. So in our next class, we have to look at that and solve illustration 3 and illustration 4. So illustration 3 is talking about a production line that has 50 identical components. So this is not assets. And these components can fail on a regular basis. And we are asked to calculate the cost of replacing a failed component. I'm not asking you to solve this. I'm just asking you to look at them, because in the next class, we are just going to solve these questions. Then the same thing here on illustration 4. Illustration 4 is the same question with illustration 3, but there are some changes. The cost of replacing a single component during the group replacement. Now, this is group replacement. This other one in illustration 3 is single replacement. That's why we are asked to calculate the cost of replacing one component that failed. Now we are asked to calculate the cost associated with different replacement cycles and make a decision. That's what we'll be doing in our next class. So thank you so much. Like I said before, today's class is going to be a short one because the topic is a short topic. So do well to do that assignment and submit to me so that I can comment and observe if you really understand this topic. Understanding this particular topic, this particular side, will enable you to be able to understand illustration 3 and 4 when we solve it. So thank you so much and do have a lovely night.